You are design engineer. You design product, a universal joint. You created CAD model and checked the assembly in CAD. No interference in assembly, so you make drawing from 3D model. All dimensions derived from it. So far, so good. Here is Twister. No machine in the world is capable to manufacture a part with same size and shape every time. There exists variation in machine, so in part size. Being a design engineer, one must consider this variation of dimension in the design. This variation of size is called tolerance. Now, the question is, if every part vary in size, how one will make sure there always be an assembly possible? The answer is tolerance stack-up analysis. Let's study this. Go back to our design, universal joint. Cut the part at the center to see contributing factor for dimension variation. When part is at lower and upper limit of its size, there are three possibilities. First, the exact match situation, which is like in design position. Second, there will be a loose fitment of parts. That is a clearance between collar and yoke outer surface. Interference situation, most critical, because assembly will not be possible in this situation. Let's focus on interference situation. These are the parts which contribute the assembly interface. If you observe, maximum interference occur when yoke size maximum, pin size minimum and collar size maximum. When these yoke and pin assemble, there will be 3 mm space available to fit the collar in. But collar center distance is 5 mm, hence the interference between collar and yoke is 2 mm. What if I told you that we have just finished a worst-case tolerance stack-up analysis? Wasn't that simple? Now, we will do same in more systematic manner. Let's go back to universal joint assembly. We have to find out the minimum and maximum gap between yoke and collar. For calculation, we consider this as x. Before start, let's understand few conventions. First, arrow mark is used to create a loop. Point from where arrow start is called tail and where arrow ends is called head. Arrow moving upside or right side will consider positive. And arrow moving downward or left side consider as negative. Second, start loop from one end of gap and finish on other end. Assign arrow to stack up contributing dimension. Name them y1, y2, y3 and so on. When you start the stack up, spend some time to read the part drawings. You will notice gap will vary if 1. Collar size changes which noted as y3. 2. Collar position change. Collar position in assembly depend on hole position on pin, noted as y2. 3. Yoke size change, noted as y1. Create table and mention all the dimensions in it. Like y1, dimension 80 for millimeters. Tolerance of plus and minus 1 mm. y2, dimension 89 mm. Tolerance of plus and minus 1 mm. For y3, tolerance is unilateral. That is, only lower side. To do the stack-up analysis, we have to convert unilateral tolerance into bilateral tolerance. How we will do it? Calculate the average of upper tolerance limit and lower tolerance limit. Same as for dimension, upper specified limit plus lower specified limit divided by 2. Therefore, new y3 value will be 4.75 and tolerance, plus and minus 0.25. Now, do the total of dimensions and total of tolerances. Caution, this is not the gap value, this is mean of the gap value. Let's check what it means. When we are measuring the gap between collar and yoke, we are actually checking how much collar face moves upside or downside with respect to yoke face. The mean value we get is 0.25. That is, color surface is 0.25 millimeters away from yolk surface. Remember the sign convention, the value is negative, so color mean surface moves downside. Somewhere here. From mean, color can move to 0.5 millimeters upside, create interference of 0.25 minus to 0.5 equals to 2 millimeters. Color can also move in downward side by to 0.5 millimeters, creating gap of 0.25 plus to 0.5 equals 2 to 0.5 millimeters. Remember, as GD and T, datum structure added in drawing, looping sequence can be changes and stack up analysis can be tricky task. But, the method to do worst case stack up analysis will remain same. Hope you understand the concept. Thank you for watching. We will come back soon with new engineering topic. Till then, stay tuned and stay happy.